Welcome to The Explainer. Today, we're pulling back the curtain on SQL Server's hidden workforce, that unseen army of worker threads that handles every single thing you ask your database to do. And trust me, understanding how they really work is the key to unlocking some serious performance. So here's our game plan. We're going to start with the problem, why the default way of doing things just doesn't cut it. Then we'll get into SQL Server's really clever solution, SQLS. After that, we'll talk about a configuration setting you should probably never touch, how to spot trouble, and finally, where your focus really needs to be. Okay, so let's get right into it. Why on earth did SQL Server need to go and reinvent the wheel when it comes to managing tasks? Well, to get that, you first have to understand the world it lives in, the standard Windows environment. Just think of a worker thread as a single employee, ready and waiting to do a job for you, run a query, handle a login, whatever. But in the default Windows world, each of these employees is managed directly by the Windows operating system, and they come with some baggage, like their own memory footprint. And this is where things start to get messy for a database. See, Windows uses something called preemptive scheduling. You can think of the OS as a micromanager who can, at any moment, interrupt one of your workers because it thinks something else is more important. And in this model, SQL Server has absolutely no say in the matter.
Now, this constant interruption, it comes at a huge cost. Every single time Windows yanks a thread off the CPU to swap in another one, it has to perform this super expensive operation called context switching. The system has to go into what's called kernel mode. Think of it as the system's central command center. It's incredibly powerful, but getting in and out is a slow, resource-heavy process. For a high-speed database that's juggling thousands of tasks, this overhead is an absolute performance killer.
So how does SQL Server get around this micromanagement problem? Well, it does something brilliant. It builds its own specialized mini operating system called SQLOS that runs as a layer right on top of Windows. And this thing, SQLOS, is laser-focused on one thing and one thing only, making databases run as fast as possible. It effectively takes control of thread scheduling away from Windows, creating a system that's perfectly optimized for the unique demands of SQL Server. And this slide right here, this is the core difference. We shift from that non-cooperative, top-down approach where Windows is the boss to a cooperative one. It's an environment where the threads themselves work together like a well-oiled machine. In this new cooperative world, each thread is given a tiny slice of time on a CPU to do its work, just 4 milliseconds. Now that might not sound like a lot, but in the world of computing, it's plenty of time to get a good chunk of work done. And here's the magic. Instead of being rudely interrupted by the OS after its 4 milliseconds are up, the thread voluntarily and politely passes the baton to the next thread in line. This simple cooperative handoff is what makes SQLS so incredibly efficient. It just cuts out all that expensive context switching. Okay, so this all leads us to one of the most important and frankly most misunderstood configuration settings in all of SQL Server. This setting, max worker threads, is basically the dial that controls the total size of your database's workforce. Now, the default value is 0, which sounds a little weird, right? But 0 doesn't mean no threads. It just means, hey, SQL Server, you're the expert, you figure out the perfect number for me automatically. And look, the official guidance from Microsoft couldn't be clearer. They are practically begging you, please, don't touch this setting unless you have a really, really good data-backed reason to do so. And you know, this automatic calculation isn't some random guess. It's actually pretty sophisticated. As you can see here, SQL Server intelligently scales the number of available threads based on your server's hardware, specifically the number of CPUs you have. If you do decide to change this value manually, you are walking a tightrope. Set it too low, and your applications will start to slow down because requests are just sitting there waiting for a worker to become free. But set it too high, and you can actually make things worse, overwhelming the system with too much overhead and slowing everything down. So if you're not supposed to touch this setting, how in the world do you figure out if you have a thread-related problem? Well, you don't guess. You look for specific performance red flags. And here it is. This is the smoking gun you're looking for. Thread pool waits. When you start seeing this wait type pop up, it is a direct signal that a request came in, went to grab a worker thread, and there were none available. Your workforce is completely maxed out. And the best part is, this information isn't hidden. You can find it yourself with a really simple query. By keeping an eye on this system view, sys.dm_os_waitstats, you can spot these issues and track them over time, hopefully before they become a real crisis. Now, this is super important. Please, whatever you do not get max worker threads confused with max stop. They sound similar, but they do totally different things. Max worker threads is the total number of employees for your entire server. Max stop is the maximum number of employees you can put on a single project or query. And this right here really gets to the heart of the matter. 9 times out of 10, maybe even more, running out of threads isn't the real problem. It's just a symptom. The real culprits are things like inefficient, long-running queries or blocking issues that are essentially holding your worker threads hostage, preventing them from finishing their work and becoming available for the next request. And this brings us to the most important takeaway of this whole explainer. It's about shifting your mindset. As a DBA, your job isn't to randomly tweak advanced settings. It's to investigate and solve the underlying problems. So, here's your playbook. It's actually really simple. Step 1, leave max worker threads at its default. Just let it be. Step 2, put on your detective hat. Investigate blocking, find those long-running queries, and check your parallelism settings. And step 3, monitor. Keep an eye on those thread pull waits to see if your fixes are actually working. You see, understanding the why behind SQLOS and cooperative scheduling, it's more than just interesting trivia. It fundamentally changes how you should think about performance tuning. So the next time you're staring down a slow server, where are you going to focus your effort first? Are you going to reach for those advanced settings? Or are you going to dig in and fix the queries that are the real root of the problem?